Motors are designed to operate within a specific voltage range. There is an allowable fluctuation, typically around plus or minus 5%, which accounts for variations in the power supply. For a motor rated at 460 volts, it can generally handle voltages between 437 volts and 483 volts. Given that 480 volts falls within this range, there is typically no problem operating a 460 volt motor on a 480 volt power supply. However, the situation is different when dealing with lower voltages. A motor with a nameplate rating of 230 volts can usually tolerate voltages ranging from 218.5 volts to 241.5 volts. Supplying only 208 volts to this motor is outside the acceptable range and presents potential problems. Low voltage forces the motor to draw more current to maintain the same power output. This increased current flow generates additional heat within the motor windings. The excessive heat degrades the insulation and other components, potentially leading to premature failure. Operating a 230 volt motor on a 208 volt supply can significantly shorten its lifespan. Furthermore, if the motor fails and the low voltage condition is identified as the cause, it could void the manufacturer's warranty. The relationship between voltage, current, and power is fundamental to understanding this issue. Power is proportional to the product of voltage and current. If the voltage drops, the current must increase to deliver the same amount of power. This increased current is what leads to overheating. Consider a scenario where a motor is designed to draw 10 amps at 230 volts. If the voltage drops to 208 volts, the motor will need to draw more than 10 amps to maintain the same power output. This increased current flow causes the motor windings to heat up more than they were designed to handle. The heat generated within the motor is proportional to the square of the current. This means that even a small increase in current can lead to a significant increase in heat. The insulation within the motor windings is particularly vulnerable to excessive heat. Over time, the insulation can break down, leading to short circuits and motor failure. Bearings are also susceptible to damage from excessive heat, and the lubricant can degrade, leading to premature wear and failure. Additionally, the motor's efficiency can be affected by low voltage. When the motor draws more current, there are increased losses in the windings and other components. These losses reduce the overall efficiency of the motor, meaning that it consumes more energy to deliver the same amount of work. There are several factors to consider when selecting a motor for a specific application. Firstly, ensure that the motor's voltage rating matches the available power supply voltage. Secondly, consider the motor's horsepower rating and ensure that it is adequate for the intended load. Thirdly, take into account the ambient temperature and other environmental factors that may affect the motor's performance. It's also important to regularly inspect and maintain motors to ensure that they are operating properly. This includes checking the voltage and current, lubricating the bearings, and cleaning the motor to remove any dirt or debris. If you suspect that a motor is operating outside its rated voltage range, it's important to take corrective action immediately. This may involve adjusting the voltage of the power supply, replacing the motor with one that is compatible with the available voltage, or installing a voltage booster to increase the voltage to the appropriate level. One should consult with a qualified electrician or motor repair specialist to diagnose and resolve any voltage-related issues. They can help determine the cause of the problem and recommend the best course of action. When motors are connected to variable frequency drives, or VFDs, the voltage supplied to the motor may be different than the line voltage. VFD can adjust the voltage or frequency supplied to the motor to control its speed and torque. The output voltage of the VFD should be matched to the motor's voltage rating. If the VFD is not properly configured, it can supply too much or too little voltage to the motor, leading to problems similar to those described above. VFD can also generate harmonic currents, which can cause additional heating in the motor windings. Harmonic filters may be necessary to reduce the level of harmonic currents. When selecting a motor for use with a VFD, it's important to choose a motor that is specifically designed for VFD operation. These motors are typically built with higher quality insulation and other features to withstand the stresses of VFD operation. Also remember to check the line voltage. Line voltage drop is a voltage drop in the conductors from the transformer to the load, in this case, the motor. Voltage drop can be the result of many factors, including long conductor runs, undersized conductors, and high current draw. When there is a substantial line voltage drop, this can cause problems as well. It is always best to use conductors that are large enough to minimize voltage drop and ensure that the motor receives the proper voltage. The National Electrical Code, or NEC, provides guidelines for conductor sizing to minimize voltage drop. NEC Section 215.2 recommends a maximum voltage drop of 3% for branch circuits and 5% for feeders. When calculating voltage drop, it's important to consider the length of the conductor, the size of the conductor, the current draw, and the power factor. Voltage drop calculators are available online and can be used to simplify these calculations. Regular maintenance is key to ensuring the optimal performance and lifespan of motors. Firstly, regularly inspect motors for any signs of damage, such as cracks, loose connections, or worn insulation. Secondly, lubricate the bearings according to the manufacturer's recommendations. Over or under lubrication can both be detrimental to the bearings. Thirdly, clean the motor regularly to remove any dirt or debris that may be blocking ventilation. Fourthly, check the motor's voltage and current draw regularly to ensure that it is operating within its rated limits. Fifthly, if you notice any unusual noises or vibrations, investigate the cause and take corrective action. Motors are critical components in many industrial and commercial applications. Understanding the voltage tolerances of motors and taking steps to ensure that they are operating within their rated limits is essential for maximizing their performance and lifespan. If you don't know how, always consult with a qualified electrician or motor repair specialist.